deep into the world of units. We'll explore the fundamental measurements, their significance, and how to arrange them based on their magnitude. So, throughout history, a myriad of unit systems has emerged, tailored to distinct needs and purposes. Consider, for instance, the British or imperial system, also known as the foot, pound, second, or FPS system. So, I'm just going to pick out a pen real quick. So, we have the FPS system. So, in this system, we have the foot, we have the pound, and we have second. Okay, so FPS. All right, so surprisingly, it remains strong in the United States, as you guys have probably already known just through your education in elementary school. And it originated in Britain, but it has moved on. So in this system, the basic units for length, weight, and time are those units: foot, pound, and second. But in this system, they use weight. Okay, so for pound, this is weight, and it is not mass. Okay, then for second, this is time and length. Okay, and this will make more sense moving forward. So when it comes to the MCAT, the FPS barely makes an appearance. What we will see is the metric system. So in the metric system, this is the foundation for something we'll call SI units, which is the staple in the MCAT. So instead of looking at the FPS system, we're looking at the MKS system. Okay. So here we have meters, kilograms, and seconds. Okay. So as you can see, it's meters, kilograms, and seconds. Or alternatively, we can use the CGS system. So this is centimeter, gram, and seconds. CGS. All right. So it's noteworthy that the MKS is part of a broader SI system, which encompasses 4 other primary units. Great. So when looking at just kind of a table of SI units, we can distribute them by quantity, unit, and symbol. So I'll create the table right now: quantity, unit, symbol. So let's look at the first quantity, length. So with a length, the unit in the SI system would be meter. Okay? And then the symbol would just be a lowercase m. So we can take the first letter of the word meter and turn it into its symbol. Okay. In the SI system, remember, we use mass. We do not use weight. The unit here would be kilogram. So kilogram has to do, it relates directly to the MKS, right? The MKS, MKS stands for meters, kilograms, and seconds, while CGS represents centimeters, grams, and seconds. So they both are a part of the SI unit as a whole, but the SI units only include MKS. So for kilogram, we use kilogram. So we take kg. The other unit quantity is time. So time, the unit is second. Okay? We use the first letter of the word second and turn it into its symbol. Okay? So these are the three quantities I basically designated kind of like in the FPS. When I said FPS, I meant length, mass, time. MKS, length, mass, time. CGS, length, mass, time. So just some other quantities besides those. The other four, I'll designate that in red. We have current. Okay. Current, the unit is ampere. I don't know if I'm saying that right. So coulomb per second. And the symbol for this is A. Okay? The next quantity is amount of substance. The unit for this is mole. The symbol is mole, so it'll be the first three letters of the word mole. Ampere is the first letter of ampere, and it's the capital A. All right, temperature is the next quantity, and this is Kelvin. Okay, this is the unit we'll be using, and we'll be using a capital K. Next quantity is luminous intensity. Okay, this unit is candela. And candela will use C and D. C, D for its symbol. Great. So in each measurement system, there are base units and derived units. So we can talk about that right here. So we have base units, and we have derived units. All right, base units are the standard units around which the system itself is designed. Okay, so if we look back to this kind of like this table right here, meter, kilogram, second, those would be base units. That's kind of what the system itself is designed around. So moving forward, derived units, as the name implies, are created by associating the base units with each other. So for example, we have Newton, right? So Newton is a derived unit. It's a unit of force, and it is derived from kilogram, meters, and seconds, right? So what is the equation for unit? So 1 Newton, or 1 Newton, is equal to 1 kilogram multiplied by, one Newton is equal to 1, and then this is the derived unit of Newton. So kilogram times meters all over seconds squared. So yeah, that's an example of a derived unit because it takes the kilogram, meter, and second, which are all base units. Cool. So prefixes for metric units and conversions between metric and imperial units. We will discuss that later. But for now, we can go into creating a table for derived units. So we already discussed what Newton is. So let me just create quantity. Okay, and then I'm going to create FPS, CGS, and MKS. And remember, MKS is what we'll be using, or what we'll be seeing most often on the MCAT. So for quantity, we have mass, force, work, and energy, and power. So in the FPS system, this was the British design system where we have pounds, seconds, and feet. The designation for mass isn't a singular unit because we only have weight. So what we do have instead is something called slug. So slug is, actually, let me use a different marker for this. So for slug, what we have is, I'll just write down slug, and what slug represents is pounds times seconds squared over feet. Okay? That's one designation for mass. Another designation for mass is something called blob. So with blob, it's pounds times seconds squared over inches. So both are used to represent the quantity mass. You can't use it, or you can't find it in the basic unit in FPS system. But for the CGES and MKS system, the basic unit's already there. It is just grams or kilograms. So we don't have to put anything there. So for force, we don't have anything in the FPS system. In the centimeter, gram, and second system, we have something called dyne. Right? So dyne is gram times centimeter all over second squared. So if we go back to looking at newtons, that's what we'll see in the MKS system. So we just went over that. Newton is kilogram times meter all over second squared. So that is, we already went over that. So Newton is a derived unit, and so is dyne. Dyne is a derived unit, but instead of using kilogram, it uses gram. And instead of using meter, it uses centimeters. For work and energy, in the FPS system, we say foot, pound, and this is designated by feet times pound, those units. For the CGS system, we have erg. Okay, erg is grams times centimeters squared all over second squared. And then in the MKS system, we have joules. Joules is kilogram times meter squared all over second squared. So just if we move forward from force to work and energy, you can see that the mass gets squared right here, and the centimeter gets squared from dyne to erg. In power, we use foot, pound, second. So foot pound and then multiplied by second in the FPS system. In the CGS system, it is basically just erg per second. So it's just grams times centimeters squared times s. Or you can just say, get rid of this and just say that this is s to the power of 3. And then in the MKS system, it isn't called joule per second. We have a name for it. It's called watt. And for watt, it's kilograms times meter second. And then just like here, we divide it by seconds. So it'll be s to the power of 3. Cool. So at the molecular and atomic sublevel, different units may be given that are easier to work with at a small scale. So I can go ahead and talk about that. So what we have is, for example, we have something called angstroms. Two dots right there, and then we have the circular thing right there. So 1A, and this is different from ampere, it has a little dot right there, is equal to 10 to the power of negative 10 meters. Or we can talk about nanometers. Nanometers. So 1 nanometer is equal to 10 to the power of negative 9 meters. So energy on the atomic scale can be expressed in electron volts. So for the unit electron volts, we have 1 eV is equal to 1.6 times 10 to the power of negative 19 joules. So as you can see here, for this one, we're taking a derived unit and we're relating it to another unit, electron volts. For these are two basic units. And for electron volts, this represents the amount of energy gained by an electron accelerating for a potential difference of 1 volt. So for the MCAT, it is good to be aware of the various systems of measurement, but the only system that we need to know is the SI system. So if we look at this graph, the only units that we need to get ourselves accustomed with are right here. And for these units right here. So this is an important table because it shows the first 3 important units that we've been talking about: length, mass, and time, and these units. The MKS system, again, as shown here, is different from the FPS and CGS. So just to test our knowledge, one question we might be asked is if the Newton is the product of kilograms and meters per second. So if Newton is the product of kilograms and meters per second, so kg times m over second squared, what units comprise the pound? So pound is part of the, if we look back, pound is part of the FPS system. So if we're just thinking about, how can we change, well, let's dissect this. So if we take this, kg m over s, right? So seconds is time, m is mass, or sorry, m is not mass, it's length, kg is mass. So one of the things that we're missing in the KGS or FPS system is the mass, right? Because we don't have a unit for that. What we do have units for our length and time, so we can just insert that right here. So for length, it would be feet. And then for time, it would just be seconds, right? And then the derived unit we can say is slug, right? Because as we can see here, slug is the derived unit we develop for mass in the FPS system. So we can, just write slug, or we can write pounds times seconds squared over feet times feet over seconds. So force basically will obey the same relationship with mass and acceleration, regardless of the unit system. force is always going to be the product of mass times acceleration. So this is going to be the acceleration, and this is going to be the mass. So knowing this, 1 pound must always be equal to 1 slug times feet second squared. Another thing that we might be asked is, what are the, so if we have, let's say, centimeter, angstrom, inch, mile, and foot, how do we order these units from smallest to largest? So centimeter is part of the MKS, inch is part of the FPS, foot is part of the FPS. Okay, angstrom is derived from the MKS, and mile is a part of the FPS. So if we want to create some kind of designation or kind of correlation between all these three variables, we can start separating these two groups and comparing this angstrom with centimeters and inch, mile, and foot. So as we looked for, angstrom is 1 angstrom is 10 to the power of negative 10 meters. So negative 10 meters, right? And centimeters will be 10 to the power of negative 2 meters. So we know that this is going to be greater than the angstrom. Now let's look at the FPS system. The mile, for the inch, or sorry, for feet, we know that there's 12 inches in 1 feet. So we know that in the inch, this will be less than a foot for sure. And then the mile, I think this is just common knowledge that a mile is greater than a foot. Okay, so knowing that, how can we correlate the lowest value here? So how can we relate the lowest value here to a centimeter? Well, we know that an inch is at least greater than a centimeter just on a ruler stick. So we can say that it'll be angstrom, centimeter, inch, foot,